Now, dear students, we have added our pads as well as the mounting holes. So let's just save our work. Now, the next step is to add front fabrication layer. Front fabrication layer, it is very important to add in the in your footprint. It is actual outline of your component. Like in our case, we have this. These are our PCB mounting, that footprint we have just designed, while on the left side this is the actual outline or the actual dimension of our component or the actual space that our slide switch will cover on the PCB. So it has length of 8.6 mm and a width of 6.80 mm. So let's just draw the component outline. So you have to specify your component outline in the front fabrication layer. On the right side you can either choose front fab. This is the front assembly on the board's front, the front fab layer, or you can go over here and choose your front fab layer. Both both are the same things. You can choose either select your layer from this appearance layer section or from this drop down menu. So once you select your front fab, you can either do you can draw a line, an arc, or a rectangular, circle, or whatever thing you want. But in our case we have a rectangular to draw for our component. So in our footprint, let's choose the rectangle and click over here and click again to draw the rectangle. Escape, and now click on this and hit E. As you can see that we have dimensions of 8.60 on X direction and 6.80 on Y direction. Let me add this directly into this rectangle. So it has a start point. Let me start my rectangle from 0 and again 0, and the end point, for end point let me choose 8.60 X direction, 6.80 in Y direction. 8.60 and in Y 6.80. let me check 8.60, 6.80 and hit OK. Now this is the exact outline of our component, which is 8.60 and 6.80 in Y direction. So let's just hold this and place it over here. Let's just make a symmetrical. So this is our actual component outline in front fabrication layer. So this is one way to draw your front fabrication layer. Another way is to actually calculate the coordinates. Which coordinates? Like this one, if I select this rectangle, hit E, you can see over here there is a start point X and Y, end point X and Y. So you can also calculate the start and end point of X and Y. As you can see over here, I have just made in the slide. This is the front fab which we have to draw, already have drawn, and I have calculated its start point X at 2.10 and Y is equal to minus 2.15. So I did this. Let's check the data sheet. I have to actually as you know that our pin number 1 is at origin 00. So when I place this rectangle over here on my footprint, my left top corner will be on the left of this origin and above this region. So I have just calculated a start point as minus 2.1 and minus 2.15. Similarly, my right bottom corner, this one will come over here. So I have calculated this point as 6.1 and 4.65. This is pure calculation from the dimensions given in the data sheet. Like these dimensions, I have used these dimensions and these x and y dimensions to exactly make my front fabrication very symmetrical to the pinouts. So either way you can do this. So let me enter our start point. I have calculated as 2.1 and 2.15. This is 2.1 and 2.15, and my y coordinate endpoint, my endpoint is 6.1 and 4.65. 6.1, 6.1 and 4.15. I have just calculated to make it very precise and accurate. Otherwise you can also do as I have just told you, by drag make a rectangle and just place it on the footprint in a very symmetry. So let's hit OK. Now we have drawn our front fabrication layer. In front fabrication layer we draw the actual outline of our component. So let's hit save. So the next thing is, after you draw a front fabrication, the next thing is you have to draw the silk screen. So first of all, let me show you my footprint in 3D viewer. Go to view and click 3D viewer, and here is my footprint. You can see over there is no outline that can, let me move this thing a little down, and now hit save, go to view, 3D viewer, and this is my footprint right now. The next thing what we have to do is that we have to draw some outline that can also be printed on my PCB. So in order to draw the outline, what we do, we will choose front silk screen. On the front silk screen you are now draw a rectangle. Let me draw this rectangle over here, like this, and little above. So I have now drawn my front silk screen. Front silk screen will help us to identify the complete component on our footprint. Hit save. Let me show you in 3D viewer. Now you can see there is a white outline. This white outline now specifies that this is a single footprint for our slide switch. So we have now drawn front silk screen. The next thing is we have to draw courtyard. So let's go to courtyard layer. This is our front courtyard. The courtyard layer will help us to specify the boundaries of the component, that if any other component enters into the boundary of this component, then while you perform DRC, the KiCad will give an error that there are components that are overlapping. So courtyard layer is very important while you design a footprint. So similarly, go to draw rectangle and click over here on the silk screen. You can also draw a little out of the silk screen, and like this, let's make it symmetrical. So click over here, and this is the courtyard of your footprint. Hit save, and let's again check in the 3D viewer. You can see there is no difference, but we while designing the PCB, if you place any other component over here overlapping this courtyard of this component, then the DRC will give an error. So hit save. Now to summarize what we have done while designing the footprint is, the number one thing, we have placed the pins 1 2 3 4 and 5 6 by calculating the exact dimensions from the data sheet of this component. The second step, we have added the mounting holes, which are non-plated through holes on the left and right. In the third step, we have added a boundary, actual boundary of the component, which is done in front fabrication layer. And in the next step, we have added silk screen that helps us to identify a complete component or a footprint on the PCB. In the next step, then we have added coat layer in the front courtyard layer, so that any other component that overlaps into or comes into the area of this courtyard, the DRC will give an error. So in this way, we design our footprints in KiCad using footprint editor.